Okay, so you got your quizzes back. Are they making their way? Nice. I like to keep the grade quiet, so it's on the inside. You'll find it. It's out of 22, and so just make sure that I've kind of. So I work on a. If you're not familiar with how I mark, everyone starts at 100%, and then I deduct marks. So you don't have to work your way up to a certain answer, if that makes sense. But I do deduct marks if I see something that doesn't jibe with what I want. So, and I try to make little notes. But if you have any questions about, why did you take a mark off here? When I do 1/2, it's just 1/2. So instead of 0.5. And so if you have any questions about the marking, but otherwise they are just out of the textbook, right? So I've got the solutions, basically. Okay, let's see here. I think we're ready. So today, we're going to do chapter 8, which is on multiple regression. Oh, I don't know if let's see here. Kind of a snow day, so I'm glad to see people online. If you can't make it. Okay, so not really a snow day, but I don't know, just felt like it. So multiple regression, but first let's talk about just simple linear regression from last day. Simple linear regression, we had an equation for, right? We had y hat is b0 plus b1 x, y hat being the predicted value of y, right? And so predicted value of y, which points us in the direction of what we're going to be doing with this line, is to predict new values of y given some input x. Okay? And so the b1 is the slope and b0 is the y-intercept. We talked about how to interpret the slope and the intercept, okay, which we're going to talk more about today. But I want to focus on the slope, because as soon as we get into multiple regression, now multiple regression is going to, just as a preview, is going to look like this. b0 plus b1 x1 plus b2 x2 plus blah, 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 all the way up to bk xk. We usually use k. Wait. So, what's the difference? What's the diff? Well, we have multiple explanatory variables, right? And so that's what makes it multiple regression. So here we have multiple explanatory variables. So each of them have a coefficient. That's no longer going to be the slope, but it kind of behaves in a similar way, right? And so that's what we're going to develop today. So it's just an extension of, right here, if we wanted to, we could have b1 x1. So simple linear regression just refers to one value of x. whereas multiple linear regression talks about multiple values of x, right? And so usually if we have a data set, we don't want to just talk about how y relates to some one value of x. We want to try to incorporate multiple things. Okay? And so the example that we're going to use from the textbook is this loan data, which we've seen before. Here's your data dictionary, right? Or a version of it. This is to help us figure out, okay, what's included in our data set. They also include kind of a snapshot of what this data looks like typically. And because I have room, I'll just sneak it in here. I'm not going to make it big in the notes, just small, but I'll zoom in. So we've got information on loans. Okay, so some lending club, I think it is. And so we've got the interest rate, which the borrower got. So the interest rate that they got on a loan. Verified income is a categorical variable. Okay. Now, the verified income has multiple levels. So it can either be verified, so which means that the source and the amount have been verified. So the source of their income and the amount of their income has been verified. Okay. And alternatively, their source could be verified. So just the source of their income could be verified, which implies that the amount was not verified, right? And not verified. Okay. And so we've got these different levels, right, for one categorical variable. Okay. And so we didn't talk about that last day. And so what I want to do is just kind of skip ahead. So we've got the debt to income ratio, which is also another common measurement. So the percentage of total debt divided by their total income, right? And you've got the credit utilized, I think is what the util is for, but you've got some fraction of credit that they're utilizing versus what they have available. So usually they look at, okay, well, what's your credit limit on your credit card and how much of that is borrowed? And usually you want to use a small amount, right, is the goal, because then that credit ratio looks good. Okay. Bankruptcy is an indicator variable, which we'll talk about. Okay. And so an indicator variable is sometimes called a dummy variable, which I think is more fun, or maybe mean. But it's just kind of fun to throw that around if you're talking to someone. Oh, you just need a dummy variable, which is an indicator variable. And so here, an indicator variable is also known as a dummy variable. So a dummy variable is if the outcome is just 0, 1. I wish we could unlock these doors. They should just be unlocked. And so a dummy variable or an indicator variable only has binary outcomes. And so it's kind of like an on-off switch. 0 is off, 1 is on, and or yes and no. And so we have yes or no as our possible levels, right? And so this would translate to a 1 or a 0. So that's the one that we're going to start looking at in terms of, because the bankruptcy variable is 1x, right? And so one of these variables. But when we have multiple levels, what happens is we kind of spread them out and create dummy variables for each level. Okay? So that's what I want to show you and start with, and then we'll build into incorporating more of these variables. And I'm pretty sure the goal is to be able to predict what interest rate a borrower would get. Okay? The term of the loan is the length of the loan in months. Okay? The issue month is for all these loans is the first quarter of 2018. Okay? And then the credit checks is the number of credit checks in the last 12 months. Okay? So usually if you apply for a credit card and things like that, they do a credit check, which if you have a lot of credit checks, they start to get suspicious and they say, okay, why are you applying for so much credit? And so that's why you want to be careful about that. But so that's another one of these variables that we have is, well, how many credit checks have they had done? Okay, so what we're going to do is we're going to build, it's not really review, we're just kind of jumping into it. So because we didn't talk about categorical explanatory variables last day. Okay? And so last day we had a numerical response variable and a numerical explanatory variable. Okay? And so today we consider numerical response. Why? If we're doing regression, then it will be a numerical response variable. Okay? In the next chapter, we'll look at how do we predict categorical outcomes, right? And so we will be able to predict categorical outcomes, but for now, we're just focusing on numerical outcomes. And so we consider a numerical response Y with a categorical explanatory variable. X. Okay. We're going to start with an indicator variable. Let X be bankruptcy. Right, which is 0 for no and 1 for yes. Right, they have declared bankruptcy. Is there some just has a past bankruptcy in their record? So I thought maybe in the past 5 years or something, but it's just forever, I guess. Seems reasonable. And so now we have this indicator variable. Okay? And what our model is going to look like, okay, because our X is the bankruptcy, we can build our model Y hat, which we're gonna predict, let's do that, and let Y be the interest rate. Which is a numerical response. Okay. So we want to predict the interest rate depending on if they have declared bankruptcy in the past or no. Okay. And so usually what we do is, let me just grab the, if it's just an indicator variable, we have y hat is some slope, or sorry, so some intercept, sorry, and b1 times x, right? That's generic. So in our case, we're going to have some predicted interest rate with some intercept and some slope on bankruptcy. Bankruptcy can only be 0 or 1. And so instead of it being the slope, it still kind of works, but bankruptcy only moves between 0 or 1, right? And so here, this is 0 or 1. 0 if it's no, and 1 if it's yes. And so from here, let's predict the interest rate. Oh, that's why I grabbed it. I need the values. We're not going to calculate slope and the intercept here. The output would look something like this. And so we get our intercept, right? The estimate for our intercept is here. And so I'll just kind of highlight that. And for now, okay, we'll just kind of, we'll just kind of ignore this stuff. I don't want to ignore it completely. We're going to come back to it. But we need some more knowledge about p-values and things like that. And so that's why for now, you can just kind of ignore it. Okay, we're just here for the estimates. Okay. So then, if we use this output, just like we did last day, then we can write out our model, which says that the interest rate and the predicted interest rate is 12.34. Hey, 1, 2, 3, 4. Plus 0.74 times the bankruptcy. Here they've indicated that bankruptcy 1, but because it's a 0-1 variable, there are only 2 options. And so now, why don't we need a bankruptcy 0? Because if I just force this to be 0, right, then I get an interest rate, I get a predicted interest rate. And if I force this to be 1, the multiplication is just 0.74 times 0 or 0.74 times 1, right? A lot easier than it was last day, in my opinion, right? Where we had to plug in values of x and multiply by the slope. So the predicted interest rate for no bankruptcies is 12.34 plus 0.7, oops, 74. 0. Right. So that switches off. And that puts me at a predicted interest rate of 12.34. What if they have declared bankruptcy at some point? Right. What about yes bankruptcies? Oops, let me see if I can. Maybe just singular. We don't know if there's a number of them. Then the predicted interest rate is 12.34 plus 0.74 times 1, which is what? .74 higher than no bankruptcies. Say that. 12.34 plus 0.74 is 13.8. 0.08%, but who cares about units, right? And so those are predicted interest rates with just this categorical variable as our explanatory variable. And because it just has that on-off switch, right? It's just got this binary outcome 0, 1, right? Then we only need to incorporate the 1, right? And then if it's not 1, then it's times 0, and then your predicted value is just the intercept. And so let's remind ourselves what the interpretation of the slope was. The slope, or the interpretation of the slope from last day was for each unit increase in x, for each unit increase in x, we expect a slope increase in the predicted value of y. We expect a slope or B1 increase in the predicted value of y. Or shorthand y hat. So here, that's still true, but you can only go one unit increase, right, from 0 to 1. And so now we see it, that the predicted interest rate went from 12.34, and then it went up 0.74 when we went from by a 1 unit increase from 0 to 1 in x. And that's really all we can do. And so the interpretation stays the same. It's just a little bit simpler for these indicator variables or dummy variables. So what happens if we have more than just 2 levels? So here, right, if I have 2 levels for bankruptcy, I only had to incorporate one of those, and then the rest fell on just the other one, right? And so we're going to use that same method, right? Because here, if I have bankruptcy, and I'll just match it. Sorry, I should have bankruptcy 1 there, just to match this output. If bankruptcy 1 is off, then it's 0, right? And so then we get just the predicted interest rate is just the y-intercept, right? So everything is just kind of put on the y-intercept, and the y-intercept incorporates no bankruptcies, right? And so here, the y-intercept incorporates no bankruptcies. Right? It's kind of rolled into the y-intercept. Okay? We're going to start calling it a reference level. So no bankruptcies is the default. Okay? And so therefore, no bankruptcies. I wish there was something easier to spell. No bankruptcies. Hopefully I'm doing it right. The trick is to make it illegible. No bankruptcies is the default or reference level, we're going to call it. So what if we have a categorical variable with more than 2 levels? We're going to do the same thing. Usually the software will just, or Excel in our case, will just pick a reference level. Okay? And so it'll just pick one, and then all the other predictions will build off of that reference level. Okay? So let's grab some output. And have a look. Consider X, which is the, what was it called? Verified something. Verified income. Which has 3 levels. Consider X to be the verified income, which has 3 levels. Right? It's a categorical variable with 3 levels. And so now, let's see here. Let me paste this. I'll grab the levels before we keep going here. Copy. So our levels are verified, source verified, and not verified. And so verified is both source and income. So now we have these 3 levels. And so if we're given output, which at this point, so last week, we spent time and we looked at, okay, if I give you some information about the standard deviations and the means and the correlation, then you'll be able to calculate some brief slopes and y-intercepts. We're only going to do that for simple linear regression. For multiple regression, I'll give you output like this, and you just have to be able to extract the information that you need. And so something like this, notice that you have the verified income, but now you have the level attached to it. So the level, source verified or just verified. Which means, okay, let's see here. If I map these, oh wow, I did these in a weird way, didn't I? Whoa, that guy's there. So the verified level, right? You can turn it on or you could turn it off. Okay? And so what we've done is each of these levels are considered indicators, right? And so, but let's map the source verified. Maybe I'll use a different color. Source verified is here, which means that not verified is our reference letter, oh my. Our reference level. So close though. Different meanings. So now, I've got my not verified is lumped into the intercept. And so here, what we've done is, notice each level has been turned into an indicator variable or a dummy variable. Which do you prefer? I don't want to keep saying both. Indicator sounds nicer, doesn't it? Each level has been turned into an indicator variable. so now, right, which means that each of these two, right, are going to be baked into our model. And so now our model looks like this. Our interest rate hat, which is our predicted interest rate still, is 11.10 plus 1.42 and times verified income. I wish it was shorter. And then we're going to use the subscript source verified. So because it doesn't produce subscripts, and so source verified. Plus 3.25 times verified income. Verified. Right, which was both were verified, both the source and the income. Oh. I should clarify here, the source verified is only source verified. Right, so there's no overlap here with the source, with the both source and income and versus the only source. You can only have one of those apply to you. Okay, so what's the predicted interest rate for someone who has had neither of those things verified? Right. If we think about, okay, so not verified, we said is going to be lumped into the intercept. And the reason for that is because if someone didn't have anything verified, right, their source wasn't verified and their amount wasn't verified, then the verified income source verified would be turned off, right? And so it would be 0, right? Because they had neither verified. And both verified, well, that would also be turned off, right? And so you put that to 0, right? I like these on-off switches. I imagine my model is kind of in a lineup like this, and I just turn on my switches that I want, and then I can find my predicted values, right? And so here, as an example, find the predicted interest rate of a borrower who has not had anything verified, or who has not had source nor amount of income verified. If I cheat, root, copy, paste. Then this, if neither was verified, right, is going to be set to 0, right? The source verified is 0. And then the verified income, all of it verified, is also equal to 0. The math here is not too bad, right? The predicted interest rate is 11.10 plus 1.42 times 0 plus 3.25 times 0. Nice. Which puts me at 11.1. Okay. What's kind of confusing then is you would think that if your income was verified, that would be a good thing. But what happens to your interest rate? And you should be rewarded. right? With a lower interest rate. But what does this say, right? What if your income, so let's do another one. For example, predict the interest rate for a borrower who has had their, let's start with the source verified, who had their income source verified. So now, I paste this in. I know it's cheating. Now, the source verified, so they had their income source verified, which means that this is turned on. They didn't have both verified, and so this is still off, right? Only one of those can be on at the same time. And so I get 11.10 plus 1.42 times 1 plus 3.25 times 0. So I get a predicted interest rate of 11.1 plus 1.42, which is 12.52. A higher interest rate, if you had your source verified. Not cool. Not cool. You should be rewarded. But there are always things that we don't know, right? And so maybe there was a reason that the bank or the lenders were kind of suspicious of your sources, and that's why they had to verify it, right? And so that's why you kind of want to be, you want to be looking at these things, but also considering other factors that could be contributing to these values that we haven't taken into account. Right? And so here, right, this is higher than not verified, if I can use that kind of slangy shorthand. How much higher? 1.42 higher, right? And so that's from this coefficient here, right? And so it's 1.42 higher than not verified. And so the not verified, we said, was our reference letter. Oh my gosh. You guys are going to call it your reference letter. Level, Emily. Right? And so we've got our reference level. And all the other ones are on top of that reference level, right? And so I've written too many reference letters. Okay, so what about if both were verified? Yeah. And so what about predict the interest rate for a borrower with both income and source verified? So if it's both, then this what colors did I use? This guy's off because it's both. And so the source verified is if only the source is verified. And color did I use for on? Orange. And if both, then that's the verified variable, which is going to be on now. The 3.25, again, is relative to not verified, right? So in addition to the not verified prediction, right, we would go up 3.25% in interest rate if both the source and the income were verified. Okay. And so here we get 11.10 plus 1.42 times 0. And if you're writing out your predictions like this and you're doing 0, I still want to see the coefficient times 0, right? Because you don't want to lose it in your model. And so it's tempting to just drop it because it is just 0. But when you write it out, I want to see it like this, 3.25 times 1. And so you get, well, 3.25 up from 11.1, 14.35%, which is the highest. Okay. Right. A little bit counterintuitive, but there's always a chance that there are other factors that we haven't taken into account in our model, right? And so the higher interest rate, for borrowers with verified income or maybe I should say verified sources and or income, just to incorporate both of those indicator variables. So the higher interest rate for borrowers with verified sources and or income is counterintuitive. But it's possible that there are other factors that we have not taken into account. There are other factors that have not been taken into account. Right. What spurred the lender to go, hey, can we just verify that income that you said you had? Would you? Right. Can we just follow up on that? And these are small loans, right? You always have to verify your income if you're getting a mortgage and things like that, obviously, but they don't give those out for free anymore. So, right. And so other factors, but I know what you want to do is, well, how can we incorporate those other factors? Well, buckle up. What if we incorporated all the variables, right? Let's toss those all into a model. And of course, this is click, 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 click in Excel, and then it produces it for you. And so our job is to be able to, well, one, produce it, but also read the output and interpret the output, right? And so now, what if we build a model which incorporates all the variables in our data set, right? That may be a lot of them, and it may be a few of them, right, depending on the size of your data set. But usually we have kind of a reasonable number of variables. And so what if we build a model that incorporates all the variables in our data set? What would that look like? We'd get output that looks something like this. There it is. I'm gonna move this over here. So then I'll just say here, you would use Excel. I'll show you how, but for now, let's just look at the output. All right, we need to be able to read it before we produce it. So just as before, our kind of go-to column for now is this estimate column. Bless you. And we have all these either indicators or just explanatory variables listed on the side here. Okay. This is split over 2 rows. It shouldn't be. I think they should have made it wider. But anyways, so this is income source verified. And then you can ditch that. Here, we've already seen these variables. This is the verified income variable split by the 3 levels, right? I say 3 because the reference level is incorporated into the intercept again. And then we have some numerical explanatory variables, right? I've got my debt to income ratio. I've got my credit utilization, I think. And so these guys are numerical. The bankruptcy one, right, is another indicator variable. And again, the 1 is incorporated here, but the 0 is in the intercept, right? It's also baked into the reference level. And so, and then the term is a numerical variable. And so here, the term and the credit checks was the number of credit checks that they'd had done probably in some amount of time. Okay. And so these are both numerical. And then the issue month, January, March, and was it in the first quarter? Probably February, I have to assume. Right. And so here we've got another indicator. I'll add indicator here and indicator here. I think it was they all happen in the first quarter of 2018, which puts me at February for my reference level, right? I see January, I see March, right? But I'm missing February. Let's just go, usually if I'm unsure, which I am right now, of what the levels were. Maybe first quarter of 2018. Then I can go poke into the data and see, okay, yeah, January, February, March confirms that those are in the first quarter. Confusingly, the quarters of the years have 3 months, which always throws people off. It doesn't, but it does in a weird way. Think about it. And so here, the indicator with the reference level February 2018, right? Issue month, and then we've spread it out over the levels. It's either January or February or March, right? It can't be any overlapping there, right? Same thing with the bankruptcy, right? You either have declared bankruptcy or you have not. Right? And then the same thing with the verified income that we saw, right? It's only one of those things. Which means that a lot of information is baked into this intercept, right? It is a borrower, right? In fact, let's try it. How do you get to only the intercept? You would have to multiply all these other values by 0, right? And so let's interpret what the intercept is. Interpret the intercept. Can I steal the model that they typed out? Because it's so much nicer. And it's long. Let's see here. What's this done? Taken 1.89, that's your intercept, plus 1 times the income source verified, plus 2.56 times the verified, plus 0.02 times the debt to income ratio, plus 4.9 times the credit utilized amount, plus 0.39 times the bankruptcy, plus 0.15 times the term. These are, a lot of these are positive, right? Which means that as you move from either 0 to 1, right, or just increase in numerical value, right, your interest rate or your predicted interest rate is going to be increasing, right? And so, right, if you incorporate all these things. So here, this is just a nicer write out than I could ever do, and it would take me a long time. And so, luckily I post my notes, so I don't feel too bad. Okay. The only one that seems to have a decrease is the issue month of March, right? We'll see if that's a significant decrease, right? For that, we need to look at these p-values, but we're holding off on that. So we'll be able to determine if it's a significant increase or decrease by looking at these values over here in the table, but that's a ways off. It's not, spoiler alert, it's not. But it is a decrease. Okay, and so for us, right, our predicted interest rate, right, depends on all these things, all these, or it is explained by all these explanatory variables. Yeah. This one. I think so. They put kind of some of these on the same line. So the bankruptcy and the term, and then the issue month, January, issue month, March. And then the February is in the intercept. So the intercept, right? If we have to look at the intercept, let's start there. Right? The intercept is when all other values are multiplied by 0. Which means something, right? It might not be meaningful, but it does mean something. And so let's have a look. So then the verified income source verified is 0, right? So they didn't have their source verified. In fact, they had neither verified. So the intercept had neither income nor source verified. Both of those are 0. They had a 0 debt to income ratio, which can happen if you have 0 debt. And so here the debt to income ratio is 0. 0 debt to income ratio. I'll say no debt. The amount of debt divided by your income. Credit utilized is 0, which means they're not using any of their credit, right? And so all their credit cards are paid off and things like that, right? And so 0 credit utilized. The bankruptcy has to be 0, right? So they can't have had any bankruptcies. 0 bankruptcies. Like that. It's not really a number, so I should say no bankruptcies, because it's a yes/no variable. The term, this is where we run into some trouble, right? The term of the loan is how long you want to borrow money for, right? For the intercept, it would be 0 amount of time, right? Which doesn't really make sense. It's not meaningful, but it is part of the intercept, right? That's our starting point, and then we build off of that. Obviously, the term can't be 0, right? But that is incorporated into the intercept. So the length of the term is 0. I think it's months. Let me confirm. But months, yeah. 0 months. Which is not useful information, right? So that's not useful. It is the starting point, right? So the one way to get your lowest interest rate, it looks like, is to borrow it for no amount of time. Wow, groundbreaking. The credit checks have to be 0, so 0 credit checks. 0 credit checks. That can happen. Issue month January has to be 0. And I'll follow it up with issue month March has to be 0. Which means the leftover one is February. Right? And so not issued in January or March. I don't know why I spelled out March and not January, but whatever. Therefore, issued in February. A borrower with these characteristics have the predicted interest rate of just the intercept, right? But what we're going to be able to do is we're going to be able to look at an individual and predict their interest rate by either adjusting and flipping on and off these income verification switches, or adjusting their debt to income ratio, and I guess I should say, looking at how much credit they're using, right? Whether they've declared bankruptcy or not, right? And so let's see here. Let's summarize that. Whoops, that wasn't very nice, was it? There. A borrower with these characteristics has a predicted interest rate of 1.89%. Unlikely, right, to find someone like that who wants to borrow for no amount of time at all. I'm pretty sure that if you even borrowed for a day, they would bump it up to a month, right? Round it up to a month. And so, because that's just these scoundrels, right? And so 0, that's the sticking point, is the length of the term being 0. Notice that this is the same way that we interpreted the intercept way back when. It was only last week, right? But if we kind of remember y hat plus, is equal to b0 plus b1 times x. Remember these good old days? Right, we had our predicted value of y. How did we interpret the intercept? We said, well, that's the predicted value of y when x is 0. So now we're doing it again, but we're turning all our x's into 0, right? And that's still going to be our intercept. So same interpretation, it just looks a little bit harder because there's more variables, but you're doing the same thing. When we interpret these coefficients or these estimates, I'll put down. One of the main things that you want to talk about is, so these are no longer slopes, right? They're kind of all working together. And if you remove one of these variables, right, then they would all kind of reshuffle and try to capture as much of the activity in y as they can, right? And so these values are going to change depending on what variables are included in our model. Okay. And so then how we interpret these estimates, and let me write that down first. The estimates of these are called predictors, of our predictors, so the explanatory variables will change depending on what other variables are incorporated in the model. Will change depending on what other variables are incorporated in the model. It would all kind of just shuffle and redistribute some wealth or some weight, right, to the other predictors if you remove some. And we'll look at that, but this links back to our interpretation of each of these each of these estimates. And so to interpret an estimate of a predictor, what we're going to say is we have to hold all the other predictors steady, right? And so they're all being held steady, nothing's being changed there, and we're just focusing on that one predictor, for example, the bankruptcy predictor, for example. Right? And so to interpret an estimate of a predictor, we need to hold all other predictors steady. And the estimate is going to be the increase from the intercept. Then the estimate will be the increase from the intercept slash the reference levels. So for example, if we want to interpret, right, let's say the number of credit checks. I think that one's kind of a nice one to look at, right? And so if we have the credit checks 0.23, so for example, interpret the estimate for the credit checks variable or predictor. Start incorporating the term predictor instead of just the random variables. So the estimate was 0.23. I lost it. 0.23. So how we need to interpret it is, okay, assuming that all other variables are held constant, right, or steady. I like to call it steady just so that they're held steady, but assuming all other predictors are held constant, we expect, and now, so once you've tackled that, all other predictors held constant or steady, then you're back to the same interpretation that we had for the slope, right? Because now you're saying, hey, hold all these guys steady. Now I'm going to focus on the credit checks, for example, right? And so now, right, what would we say? We would say for each unit increase in the credit checks, we expect a 0.23 increase in the predicted interest rate, right? And so now, assuming all other predictors are held constant, we expect a unit increase in the number of credit checks to produce a 0.23 unit increase in the predicted interest rate. So that's the same as when we just had the one value of x, right? As long as you're holding all the other things steady. Right? And so right, we can go back. I'll come back down here, but to our output and just focus here, right? If we have to interpret the term variable, for example, right, then we would say, okay, hold, is it that time already? Oh my gosh. The term variable, right, holding all others steady, then, right, holding all these other things steady, none of them are moving, right, they're held constant. Then for each additional month of the loan that you borrow, right, then you expect a 0.15 unit increase in the predicted interest rate. Right? And so that's the same to me, and it will be to you eventually, right, as just the one value of x scenario. Okay. So we built a model with all the variables from our data set, which we call the full model. And so the full model is the model that incorporates all the variables in your data set. Model that incorporates all the variables in your data set. What if you have like 20 variables? Yikes. That can happen. That's pretty reasonable, actually. And so then we get this, usually we get this scenario where we're potentially overfitting the model, right? And so we're fitting models to data, right? And that's coming from a sample, but we're really trying to build a general model that we could take to a new sample and use it to predict values, right? Without rebuilding a model. And so, right, so we want this kind of transferable model. And so to do that, you want to have as simple of a model as possible. Okay? And so the goal is to build the simplest model possible that still performs well. That's kind of implied, but I should put it here. That still performs well. How do we know model performance? We've seen R squared. And so R squared was what? I don't expect you to remember, but if I say R squared is the percentage of variability, and then you see, oh no, percentage of variability, that's R squared, right? I want you to have that connection. And so it's the percentage, or I should say R squared is the percentage of variability in y explained by the least squares regression line on x. just rolls off your tongue. The least squares regression line. Next. But like I said, as soon as you see that percentage of variability, kind of stop reading, and you've got that internal link of, okay, this is going to be R squared, right? Is it asking for R squared? Do I have the correlation, right? R squared is the correlation squared. And so R squared, if it's the correlation squared, we said is between 0 and 1, right? And if it's a percentage, right, between 0 and 100%. And a high R squared is a good model, right? In fact, it's a model that performs well. And so a high R squared means the model performs well. So we've seen that before. Right? And so, for example, if I've got an R squared of 0.49 versus an R squared of 0.73, I want this one, right? That one performs better. It's capturing more of the variability in Y, right? And so that one is better. Usually we don't have this kind of luxury. We've got very minute differences in our models, but we're going to do the same thing. It's just once we've incorporated more than one explanatory variable, we start to use the adjusted R squared. And so for multiple regression, more than one explanatory variable, we use the adjusted R squared. We use the adjusted R squared instead of just the R squared. It behaves the same way. It's just that you're penalized for having too many predictors, right? And so here, the adjusted R squared behaves the same way. Behaves as R squared, but is penalized, and penalized in this case would mean reduced, right? And so it's lowered by having too many predictors in there. And so the adjusted R squared behaves as R squared, but is penalized, which means lowered, if there are too many predictors. If too many predictors are in the model, right? This, if we have too many predictors, we call this overfitting the model. Right? You want it to be kind of as lightweight as possible. Right? So you want to incorporate all the things that you want, but not incorporating extraneous things. So that's why you use the adjusted R squared. But what we do to compare models is we compare the adjusted R squared, and we pick the one with the highest adjusted R squared. So to compare models, we compare the, and I'll just say ADJ, the adjusted R squared, or sometimes we do R squared and then subscript adjusted, or ADJ, something like that, whatever shorthand you want to use. Excel will generate the adjusted R-squared, so I'm not going to talk about the formula. The formula is in the textbook if you're interested, but it's just, you're just penalized by the number of predictors. So that's all we need to know. So to compare models, we compare the adjusted R-squared and pick the model with the highest R-squared, or the highest adjusted R-squared. For us, we're just going to do this blindly, right? Even a minute difference in adjusted R-squared, I just want you to go for the highest one, right? As you get to know your data, or maybe you have some internal knowledge about your data, and maybe if you're choosing between an adjusted R-squared of, let's say, 0.671 versus 0.672, I don't think that there's an effective difference between these two, right? And so then you want to start to think about, okay, I'm not going to pick this one if this one incorporates maybe something that's kind of expensive to measure, whereas this one maybe is able to build this performance of a model without that expensive variable. And I mean expensive in terms of maybe time or cost, right? And so there are lots of different things that go into the different variables, right? If these are all easy to collect, right, then this is a better model. If this one incorporates kind of more expensive variables, right? And so if you have knowledge about your data and how it's collected, or maybe you're doing the collection, right, that'll determine what a better model is. Okay, so for us in this course, we pick this one, right? With knowledge about the data, this one might be better or cheaper. And I use kind of cheaper in the broad sense, right? If you need to go out and buy some huge piece of machinery or expensive piece of machinery to collect that extra variable that makes your model perform so well, maybe that's not worth it, right? Because you can get a similarly performing model without it, right? And so that's why you need to have kind of some background knowledge. But in this course, just flat across the board, just pick the highest one. And so model building is kind of fun, because what you do is you just generate models upon models upon models upon models, and you're basically fishing for your highest R-squared. Okay? And so you're just rearranging variables. Now, of course, there is kind of methods to doing it, but ultimately that's all you're doing, right? Getting Excel to fit different models, and it'll produce the outputs, and you're comparing those adjusted R-squareds. There are other criterion. There's the IKK information criterion. There's what's the other ones? Who cares? We're just going to use the adjusted R-squared. So there are other criterion, the mean squared error, for example, but for us, we just use the adjusted R-squared, and that's fine, right? In industry, that's perfectly reasonable. So let's see here. To build models, you can just do it blindly. Sure, why not? We usually have kind of two ways to build models. To build models, if we usually implement says implement some structure. Okay, some structure. It's not the word I was going for, but some structure as we work through these models. The first one is called backward selection. And so, backward selection means you start with your full model, and then you take away explanatory variables or predictors one at a time. And so start with the full model. Then remove one predictor at a time, right? And rerun the model and review your adjusted R-squareds, and then pick the one with the highest adjusted R-squared. And so you start with the full model, then remove one predictor at a time. And pick the one with the highest R-squared or adjusted R-squared. It's understood that you're using the adjusted R-squared for multiple regression. And so in case I forget to say it, but I'll try to be good. Then remove one predictor at a time and pick the model with the highest adjusted R-squared. Assuming you're able to find a higher adjusted R-squared than the full model, right? Sometimes the full model is the best model, right? And that's fine. And pick the model with the highest adjusted R-squared, assuming it's higher, than the full model. That one to me is kind of difficult to do without the p-values. Usually we go for the p-values and use that as our guide, but we don't know that yet. And so then we could, do I want to incorporate it now, or they've done it for us, which is how I would do it for you. So here we have the full model, and we're told the adjusted R-squared is 0.2597. But remember, that 0.2597 is being penalized for having so many variables in there, right? And so that's why it's possible to get a higher R-squared by removing one of those things, right? And so that's why we use the adjusted R-squared, because we wouldn't get that. The R-squared is always going to increase the more things that you're trying to incorporate. So that's why we use the adjusted R-squared. Now, I think this one, we dropped the issue month, for example. And so now we have one less predictor in there, and we get an adjusted R-squared of 0.2598. Minimal increase, but good enough for us, right? We would say this is a better model because of the higher adjusted R-squared. How do I? You know what? No. I'll just bring this in instead. You've seen, you've got that output if you wanted to compare them. One thing I do want to say though, I know that, is notice how, right? that's weird. Why didn't they change the? I'm comparing these estimates. The only thing that changed by dropping this one variable is the intercept, which means none of the others absorbed any of that activity. It just got absorbed into the intercept, which is not usually the case. If we remove one, usually they kind of readjust and hold the fort, right? And so we'll see that, but let's see here. So for example, if our baseline adjusted R squared from the full model, if we're told is 0.2597, and then what we could do is we could refit the full model, but excluding each of these one at a time, right? In Excel, this would be, each would be a model, right? And so there would be a lot of output. And so, and that's where it becomes really handy to use a programming language instead, because Excel, you're kind of click, 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 and you can't recreate it. You can't, you know, control and recreate, copy, paste. You have to do it all. And if something went wrong, you have to redo it all, usually. And so that's where the benefits of a programming language come in, because there's a lot of copy pasta. Yeah.
Would you be removing it and then adding it back and removing a different one? Or
yeah, exactly.
One and then removing the next one so that you're two less variables?
For this first level, just one, or a layer, I should say, right? And so, yeah, so if you exclude the verified income, in the next model, the verified income would be included. And the only thing that's been excluded is the debt to income ratio. And then in the next one, they're all included except for the credit utilized. So if you had to pick which one of these models is an improvement from 0.2597, the only one that's better than that is this last one. And it's possible that none of them would be better, and then your full model would be your best one. And so now the next step that you would use is you would do the same thing, but now you've officially excluded the issue month, right? It doesn't matter if it was issued in January, February, or March, it turns out, right? And so, which is kind of reasonable, right? Don't want to incorporate that into your model, just bogs it down. And so now you've permanently removed this from your model building. And now you would do the same thing. So now your kind of new full model would include all the other predictors. And then you would keep going like that. And then repeat with all predictors excluding issue month. Memory serves, it doesn't get any better than that. And so you can look at the output, but let's see here. So now our kind of goalpost adjusted R squared is the 0.2598. And if we go and we cruise through, close, but not better, right? And so none of these are better, right? And so that means that that's the end of the road, right? So now we have our best model. That's from forward selection. Nope, backward selection. Well, spoiler alert, the next one is forward selection. Which I actually prefer. I can wrap my head around it easier, or more easily, I guess. And so forward selection is when you start with no variables, right? And so you start from nothing and then you move forward by slowly adding in one variable or one predictor at a time. So forward selection is where you start with no predictors then fit the model with each predictor on its own. With each predictor on its own. Only income verified, only the debt to income ratio, only the credit utilized, right? And pick the one with the highest R squared, adjusted R squared. And pick the model with the highest adjusted R squared. Has to be from the zero model. Okay, so no predictors. The adjusted R squared for zero predictors is 0. Right? Higher than 0. Right, for that first step. Because with no predictors, the adjusted R squared is 0. That's bad, but it also makes sense, right? With no predictors, you're not able to capture any of the activity in Y, right? You need to include predictors in order to be able to kind of capture that activity. And so that's nice. Now you've got a baseline of 0 and you just want to increase it from 0 as much as you can. And so what might that look like here? If we have these guys, if we had to pick the highest adjusted R squared, right? And so if we include verified income and use it as our only predictor, we get an adjusted R squared of 0.05926. That's not great. Even worse is the debt to income, so only using the debt to income ratio. And I like this one, including the term. That gives me a nice high adjusted R squared. And so then I definitely include that in my model. Okay? And then I do the same thing. And so then term, so from here, term is the first predictor included in our model. And then repeat with the remaining variables. But now you have term in there, and now you're trying to find your next best option. Repeat to find the next predictor to include. What's interesting is depending on how you select your predictors, right? Backward selection or forward selection, you often end up at different models. Yeah? And so what you could do is you could do backward selection, forward selection, compare those two, and pick the better of the two. Right? And so model building, it's just a bunch of copy paste, really. So, often, not always, but often, backward selection and forward selection yield different models. Backward selection and forward selection. Oops. Yield different models. In that case, you can compare their adjusted R-squareds. Right? In that case, we can compare their adjusted R-squared and pick the highest one. So even how you arrive at the models could give you different models to use. Right? And the different models, depending on, because those coefficients or those estimates, right, they depend on what other things are in there. So those estimates aren't always the same either, right? And so you'd have different models. Nice. Okay. Let me see. I feel like blah, 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 blah. Ah, the BIC. It's the BIC, the Bayesian information criterion. I remember the AIC, the Aikiki information criterion, but there are other ways that you could pick models. That's not for us. We did it. Wow. For the first time ever, I finished early. If you have any questions, let me know. Otherwise, I'll see you on Thursday.